Guys, I'm audible. Okay, so now, so yesterday, some little bit information I was given about cluster. So clustered and non-clustered, how it was. Okay, so same as I see the clusters. Why should we want to create? Okay, in our databases. What is the use of clustered means here? Observe. So what we said here. Okay, cluster is nothing but okay. So it is a database object. It is a database object. So which contain group of tables. Contain group of tables together. Group of tables together. Okay. Together and sharing same memory. And sharing what now? Same memory. Okay. So it's a group of tables together sharing same memory location. Okay, so that kind of the location is called as what now? Clusters. But basically these clusters, okay, in databases, especially in databases, why should we want to create these databases means in databases means. So in generally in databases, what it was happen guys here, whenever you want to creating a table. So let you see one small diagram I will explain to you. So by seeing of this diagram, you can get some idea on this. Now we can see. So non-clustered and clusters, the two diagrams, observe carefully. And first I will explain to you non-clustered. Okay, so non-clusters, what it is. Now let me see guys here. So non-clusters, simply we can say guys here, okay, it's a default clusters we got. Suppose when we are not creating clusters, by default, it is a non-clustered mechanism. Okay, so it's a non-clusters. That means whatever it is there, okay, this is called a non-cluster. In non-cluster, what it was happening here, observe. For example, we are creating so many tables in database. Okay, now we are creating so many tables in database. So whenever you created a table in database here, so every individual table will take one separate data block. Okay, one separate data block. So every table. So like you are creating, see now I'm creating T1, table 1. So when I'm creating table 1, the table 1 will take one separate memory. Table 1 will take one separate memory. Okay, now you can see. So this is table 1. It was okay, storing under one separate one data block here. Table 2 is storing under one more data block. Table 3 is storing under one more data block. Okay, so that means every individual table, when you created a table, when you created a new table in database, what it was happened, every table internally in your database memory, separate blocks are there. In those blocks, it will be go and save. In those blocks, it will be go and save. So whenever it was saving like this, whenever your tables are saving like this, then what is the problem here? On those tables, if I want to perform my joins operation, if I want to do joins, so when I perform joins operations on those tables, then what is the problem here? Observe. Suppose these are our tables, right? And every table is a non-clustered manner. It will be saved in my database memory. So non-clustered manner. That means every individual data blocks are taken here. So on these tables, suppose I'm going to writing one select query statement. I'm writing guys here. So what is my select query? Select star from T1 comma T2 comma T3, where the first condition T1 dot common column is equals to T2 dot common column, and T2 dot common column is equals to T3 dot common column. So here two conditions are there. This is first condition and this is second condition, right? So in this case, what it was happening, you can see in the first case, what it was happening in this case, okay, in this case, first of all, T1 and T1 and T2 table will be comparing here. So that means T1 table, okay, so T1 table and T2 table, these both tables are comparing together. So after comparison, whatever the result is came, the T1 is equals to T2. These two tables are comparing first of all, and whatever the result is gained, that result again storing under one more data block. Storing under one more data block. Okay. So this is one more data block. In this, your T1, T2 table data is stored here. Okay, T1 and T2 table data stored here. Okay, fine. And this is called as a data, okay, data block number 4. Okay, now fine. In the same to same second condition was that. Second condition what now? T2 dot column is equals to T3. So T2 dot or T2 is equals to T3. So T2 table and T3 table, these are two different data blocks. So these two are comparing together, then the result will be come to us. And that result also saved into one more separate data block. One more separate data block. So my point understanding now, one more separate data block. Okay, and this is called as a data block number 5. Okay, so after T2, T1 is equal to T2, this table, first table or first conditional tables data combining here, and the result is storing under data block number 4, and T2 is equals to T3. So this two tables comparing, the result will be combining and save. Okay, and after the coming out data block number 4 and 5, in between these two, which operator I'm using? I see here AND operator. Which operator? AND operator. So that means in between these results, okay, I'm using AND operator now. Okay, I'm using what now? AND operator in this final. Okay, so now AND operator, what happened? AND operator on this table and this table, the both tables, AND operator will be performed, and final result will be saved into your another data block here, the final result. So after end operation, after end logic is checked out, so whatever the final result is come out, so that final result is saved into one more data block. And this is data block number. Okay, 6. And after final result was seen, and that final result will be storing into another data block here, the data block number 6. And from here, your result, the final result is there now, that will be sending to user. That is sending to user. Okay, now all of you clear now the process how it was going on. So it is what now? Non-clustered tables. So that means when your tables are having a non-clustered manner, so what is the problem here? Can you observe? So what it was happen? So every individual table, okay, is called a non-clusters. On those individual non-clustered tables, if you want to perform some join operations, then internally this much process is going to happen. Okay. And now tell me, when this much process will be going to happen means automatically in this lengthy process, what it was happening guys here, it will be degraded your joints performance now. Okay. Now. So this is three table operation. Suppose you have a 10 tables are there, for example, assume. So I need to retrieval data from 10 tables. That means in your database memory, there are 10 blocks are there. In each block, okay, one table will be saved and stored. So from those 10 tables, if I want to retrieval data by using of joins, then you just calculate how much procedure will be internally going on, and how much time will be taken out. Okay, so that can you can easily understand. This is three table operation. This much lengthy process was happening. Suppose you have a 10 tables, then 10 tables you just assume how much time it will be taken. Okay, so that's why what the people will say, non-clusters, okay, your tables are in non-cluster manner. On those non-cluster tables, if I want to perform join operation, then it was degrading our joins performances. Okay, degrading our joint performance. Okay, so to overcome the problem, whatever it was facing here, okay, degrading joints performance, this problem to overcome purpose, the people what they will create here clusters. The people what they will create here clusters. So in clustered, what it was happening, you can see in clustered, okay. So at the time of table creations only, cluster memories are prepared. That means so clusters when it will be created, sir, means these clustered memories are created at the time of table creation. That's very important point. So when you are creating tables, at the time of table creation, automatically, at the time of table creation, we should create our clustered memories. Okay, no? So that means that before we are deciding how many tables we need to join, okay, what are the tables we need to join, okay, so those tables where you want to store in particular data block memory. So that is at the time of table creation only, it was going to be hacked. So like this, suppose here, observe guys, here there are three tables are there. T1 table, same logic, same information. Now clustered, I will explain to you. So table 1, table 2, table 3. So what we said, at the time of creation only, these three tables will be, okay, clustered together. That means they're connecting together with a common column name. How it is connected means common column. Let you see X comma X. This is called a common column. So with the help of common column, so how many tables you need to combine together and save into one data block memory. So that's your wish. Okay, any number of tables you can go to cluster, no problem. So here T1, T2, T3, these are the three tables. With the help of common column, I was combining together and saved under one data block memory. So whenever you want to clustering these tables together, and what happened, I said, these all three tables are, okay, these all three tables are already joined here, and these all three tables are storing under one data block memory. So that means the same data block memory, these all three tables are storing here. And already these three tables we are going to join already. Already we are going to be joined. So that's why what it was happened. We already joined these tables together and we stored under same data block memory. So suppose your tables are having in the clustered memories, your tables are having in the clustered memories like this, then what happened on these three tables, if I want to use my join condition, then this much lengthy process is not going to happen, which was happened on non-clustered. So that was not happened here. Already three tables are joins together. Then finally, whatever the end operator is there, end operator will be checking these all the things, and immediately the result will be sending to user. Directly, the result will go to user. The result will go to user. So that means it doesn't take much time here. Okay, na? Because already your tables are joins together based on common column, and it will be saved under same memory. So on those tables, if I want to apply join technique, then join technique, what it was going to do, whatever the operator we are using, based on this operator, directly the data will be fetching out. So that's why what it was happened here. There is no internal, that means whatever the internal process is going on in non-clustered, so that internal process is not there here. Okay, directly we are fetching our data from your clustered memories. So that's what happened here. Your joins performance will be improved here. The joins performance will be improved here. Understanding now? So non-clustered, clustered. So that means finally the conclusion, what we want to say, guys, here, clusters are used for, okay, generally clusters are used for, okay, generally clusters are used for, okay, are used for, are used to what purpose here? To improve joins performance. This is the conclusion. Okay. So why should we want to create a cluster means? So we need to improve joins performance here. Understand now? For that purpose, we need to create a cluster. But these clusters, when you create a cluster, we should have a, okay, we should have a, okay, common column name. It's a compulsory. Common column name compulsory, we should have it, because without common column name, we can't cluster our tables. Okay, cluster means combining together. Okay, now, so that cannot be possible. So that's why must and should have a common column name. Must and should be have it. And later, what I said, these clustered memories are created. Okay, these cluster memories are created at the time of, okay, at the time of table, okay, at the time of table creation. Understand? At the time of table creation, so creation only we can go to create this memory, this cluster memory. But after table creation, sir, can I apply cluster means it's not possible. Okay, so whenever you created your tables along with table creations only, okay, we are creating clustered memories. Okay, now right. So these are the few things, guys, here we should be remember when you working with the cluster. Okay, and what is the main purpose? If anybody asks you, what is the main advantage of clusters means? The clusters main advantage is what now? Improving joins performance purpose we are using. Okay, so whenever you want to perform join operations on multiple tables, okay, at that time, if your tables are clustered, then joins are very easy to performing your operations. Suppose your tables are in non-clustered manner, then it will be taking much time. Whatever I show you internal process, how it was going to be happen. So that process is going on and it will take much time, and it was degrading your joins performance. Okay, now? So this is the main, the cause of clusters. Why should we want to create it? Okay, right. But these clusters, if I want to create, guys, here, there are few steps we need to follow it. There are few steps we need to follow it. So one is called as a step one. First of all, in step one, what I want to do, I want to create my cluster. I want to create my cluster. Okay. How we can create a cluster, sir? We have a syntax here. So syntax is create cluster, and I have to take here cluster name. Okay. And what I said, when you create a cluster, compulsory, what we should require? Common column name of, so data type. Okay, common column name of data type and some size. Okay, now, so this is what we call as here your cluster creation. So create cluster name, create cluster name, common column name, and the common column data type master should be created. So this is step one, guys, here. Okay, to creating clusters. And after creating clusters, on these clusters, we need to create our indexes also. So indexes means a fast retrieving purpose. Solid indexes we created now. So create index on clusters, fastly retrieval purpose. So now this is what is the index syntax here means. Okay, we already know. So create index and index name. Okay, on. So what is your cluster here? That cluster I have to take now. I have to then cluster Okay, and later I have to send cluster name. So we created on cluster tables. So cluster name. Okay, right. And later, step number 3. What is the step number 3? Create cluster tables. Create cluster tables. So how to create cluster tables? You find out that here. And syntax, how we created general tables. So how we created general tables, same as. So create a table name, and you should pass it your columns. How many columns you require? So column, data type, and size. Okay, this is common. You know that. Like you have to declare your number of columns, how many you wanted. And what I said, at the time of cluster creation only, sorry, at the time of table creation only, we need to use a cluster. So create table name, and we are passing some column, and your last end of the column, you need to add your cluster. So cluster, and I have to send my cluster name. Okay, I have to send my cluster name, and of what basis I'm creating cluster here, common column name basis. Okay, now common column name basis I'm creating. So this is what now guys here, the 3 steps mechanism we need to follow. Okay, so first one, creating cluster. Okay, so the syntax is create cluster name and take common column name, and later create index on cluster. So create index name on cluster name, and later creating your tables. So how many tables you have to cluster together, or how many tables you need to keep into same data block memory. So that many cluster tag. Okay, now right. So after these are the 3 steps mechanism we need to follow. Now let me see one by one. We can see practically. Now as usual, you just go to open your database. So first of all, I want the table in my tablets. Okay, so these are my tables, right? Okay, fine. Okay, so now let me come out. First of all, I need to create my cluster. So I'm creating cluster, create cluster name, for example, EMPDEPT. So the common column I want to take in this. So the EPT number is my common column, and the data type is integer. So this is clustered. Okay, the block is created. Okay, now right. After that, on this clustered memory block, we need to apply some indexes mechanism. So I'm creating here create index, and index name is, for example, okay, some cluster index ci on clustered and cluster name. What is my cluster name? EMP underscore DPT. So index also successfully created. After created indexes, okay, then what is next my scenario here? I want to create my tables. I want to create my tables. So let me create your tables. How many tables you want it? So create a table, and the table name is EMP1, for example. So employee ID number, enter user, employee name, varchar 2 of size, and common column I will take your department number. Okay, right. And I need to tag here my cluster. Okay, I'm tagged with the cluster here. So cluster name is what now? EMP underscore DEPT. Okay, with the common column. What is our common column? DEPT number. So first the table is created successfully. In the same system, second table. Create table DEPT1, and here I will take now. So department number, I will take it here, DEPT number. So integer, later department name, I'm passing a bracket 2 of some size. And after that, okay, so I'm going to take in here the cluster I'm going to tag here. So what is our cluster now? So cluster name is emp underscore dept of a common column is dept number. So two tables successfully we designed guys here. After designing these two tables, okay, now you can see I'm going to insert now. So insert into record into emp1, sending values employee ID number 101. So employee name, department number 10. Okay, this is one record I inserted here. Same as 102, and now Jones and some 20 is inserted. Okay, so I saved here few records into my emp1 table. Okay, right. In the same pattern, now I want to insert some values into department table 1. So values department number 10. So department name is equal to SAP. The same to same insert into DPT 1, sending value suppose 20. The department name is database. So now we can see guys. So after designing my tables, few records I inserted into these tables now. Okay, now few records I was inserted here. Okay, right, fine. After inserted, let you call your table. Suppose emp1 table. So this is our data of emp1 and dept1. So these are the two tables data information. We can see it. And now, what is our query? That means what is our doubt is, sir, whatever we created the two tables emp1 and dept1. So these two tables are having under clustered memory. My question understand now? So these two tables emp1 and dept1, whatever we created now. So these two tables are having in the same memory location. That means same data block memory. So that how we can identify, how we can say it. So my point understand all of you. So two tables we created, right? So these two tables emp1 and the dept1, how these two tables are having in the same data block memory. Okay. So how we can identify and how we can say it and how we knows it. Okay. Now we can say that kind of doubt is coming out. Whether these tables are successfully clustered. Okay, now that kind of doubt is coming to us. Then how we can check it means here the simple thing, guys. Suppose these two tables are storing into clustered memory, otherwise into same data block memory means it's very easy to identify what now both are having in the same room or same memory means the both the tables row IDs are same. Yes or no? So both the tables row IDs are showing same ID numbers. Then both tables are having in the same table, in the same memory. Yes or no? For example, some people still have a confusion. I will tell you one small example. Yesterday, I was explain one small example to you, general example. What is our general example, guys? Here? So your friend is there. Your friend inviting to A, B, C, D, E. Okay, now these are friends. So when your friend is going to be booking total 5 rooms, total 5 rooms are booking now. And room number one, okay, the room number 1, otherwise the number is 101. In this, a friend is staying. In room number 2, What is room number? 102. In this, B friend is staying. Room number 3, number is 103. In this, my friend C was okay, staying in this. Room number 4, 104. So D person is okay, staying in this. Room number 105, and E friend is staying. So total 5 rooms I was booking here. Total 5 rooms I was booking here, and each room I allocating to my friends. Now, if I'm asking guys here, the C friend room number how much? Tell me guys, my C friend room number is how much? (103). Okay, so that means C person room number is 103. Suppose if I'm asking E person, my E friend room number how much? So my E friend room number is how much? 105. So now tell me guys here every person room number will be different. So A friend, so A person room number 101, B 102, C 103, D 104, E 105. So why sir these 5 people room numbers will be different? Come on guys, why sir these 5 people room numbers are different? Yeah, because simple, because they are staying in different rooms. They are staying in different rooms. So individual rooms are they stayed here. They stayed what now? In individual rooms. So definitely every room is having some room ID number or room number. So and these people are individually they're staying in our hotel. So that's why every room number is a different number. Okay. But guys, here this is called a non-clusters. This is called a non-clusters, right? This is called a non-clusters. For example, for example, suppose the same friend for A, B, C, D, E purpose, he was booking only one room. He was booking only one room. And the room number is 101. In 101 room, now A, comma, B, comma, C, comma, D, comma, E people are staying now. Okay. So X person what he did was booking only one room for his friends, and that all 5 friends are staying in one room. Suppose if I'm asking, what is your room number of C person? What is the room number of C person? One not one. What is the room number of E person? 101. What is the room number of A person? 101. So that means these 5 people if I want to ask what is your room number, means these 5 people are saying that 101 only. So why, sir? Why, sir, they're saying 101 only? Why, sir, they're saying 101 only? Because 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 nothing. Because what happened? They're all are staying in one room. Yes or no? They all are staying in one room. So whenever these all people are staying in one room means their room number is same. Okay, na? Concept understand na? So here also, what I'm telling here, now EMP number 1 and DEPT number 1, these two tables are, I was clustered. Clustered means, now tell me, EMP1, DEPT1, both are storing into same memory, na? Yes or no, guys? Both are storing in same memory or not? EMP1, DEPT1. Both are storing in same data block memory. Yes or no? Yes. So when both are having in the same data block memory, both are sharing same memory, then tell me both row IDs also same, na? Yes or no? Both row IDs also same or not? Yes. Now let me check the row IDs are same or not. So select the row ID from EMP1 table. Select the row ID from DEPT1 table. Now take out, guys, all of you. Your row IDs are same, both are showing same IDs. Okay, yes. So both row IDs are having in the same row IDs are showing us. So same row IDs are showing means, it means what now? This both tables are sharing same memory. Both tables are storing in same memory location. So that's why their row ID is also showing as same row IDs are showing. This is identification of your tables, whether your tables are having in the clustered memory or not. Okay, na? So in that way, you can identify your tables are clustered or non-clustered. Suppose your tables are non-clustered, then what happened? Your row IDs will not be same. Okay, suppose your tables are non-clustered, then your row IDs will not be same. Okay, na? Okay, na? right? So this is what it was going to happen. Okay. So now this is one way. This is one way to find out. Okay, this is one way to find out. Okay, so how my tables are having in the cluster or not. Okay, now right. So later on, if these clustered tables, suppose I want to see my clusters. Okay, I created whatever the clusters I created means. There one data dictionary is there, guys, here. So the data dictionary is called as here. Okay, let me check out the data dictionary. What is the data dictionary for us? So desk user underscore clusters. So user underscore clusters. This is one data dictionary. In this, you have a cluster names are there. You have a cluster name. So select cluster name from user underscore clusters. So now, as of now, how many clusters we created means here only one cluster memory we created. Okay, only one cluster we created. Okay, now fine. So now let me see. So let me see. After that, these clusters, whatever we can see it here. Okay, so suppose now I want to see that one more thing. In this is called a cluster name, but that means my clustered memory name this is. So in this cluster memory, how many tables we have it here? Understand my point now? So in this clustered memory, how many tables we are stored? Suppose what kind of tables are there in this clustered memory? If you want to see those information, then we have a one more data dictionary is there. That is called a user underscore tables. So that is called as what now? User underscore tables. In this data dictionary, we can see it. Okay, our cluster name. In this cluster, how many tables and what are the tables are there? The tables also we can see it. Now let me see guys here. Now I'm passing here. Select so table underscore name from user underscore clusters. Sorry, user underscore tables now. Tables where cluster underscore name is equal to what is my cluster name? EMP underscore DEPT is my cluster name. That is now my cluster name. Yes, EMP underscore DEPT1 cluster name. So now I just go to check it out. Now tell me guys here in my clustered memory, what are the tables we have it here? Come on. In our clustered memory, what are the tables are there? Okay, now right, two tables are there. So in this cluster memory, we have it two tables, and those tables names are EMP1 and DEPT1. Okay, now right. So this is what we can. And now suppose these cluster memory, whatever the cluster memory is there. Suppose that I want to drop this cluster memory. I want to delete my cluster memory. So we are using the syntax like that. Drop clustered, and if I use cluster name EMP underscore D. Suppose directly how we are dropping drop table name. Okay, drop view name. Drop synonym name. How we dropped here. Same to same cluster. Suppose in that manner. Suppose are you thinking in that manner? So drop cluster name. Drop cluster name. If I'm giving now, what it was happening, you can see it was showing some error. So what is the error here? What is the error means? The error telling us cluster is not empty. So your clustered memory is not empty. Is it right or not? Come on, guys. Your clustered memory is not empty. Is it correct? Huh? Is it correct now? Is it right now? Your cluster is not empty. So your database is telling that, okay, your cluster is not empty. So you can't directly drop your cluster. Your cluster is not empty and you cannot drop your cluster directly. Okay, yes, that is correct. Because in my cluster, we have two tables, we have it here, DEPT1 and EMP1. So DEPT1 and EMP1, two tables we have it. Okay, now? So that's why, yes, I can say cluster is not a empty. So that's why what it was happened, your cluster is not dropping. We cannot drop cluster directly. Then how we can drop it, sir? How we can drop means we need to add one statement that is called including tables. Which statement I want to use here? Including tables. That means drop cluster name, drop cluster name, including what your tables. So including tables statement should be added, because in my cluster memory we have it tables also, DEPT1, EMP1 tables are there. So including table statement, when we are using along with the dropping cluster, then only cluster will be dropped. Let you see now. Yes, now cluster successfully dropped here. Okay, so that's why directly we can't drop your cluster memory, because cluster memories are not empty. We have some tables in that. So that's why whenever you want to drop the clusters, compulsory we should use the including table statement. Including table statement compulsory we should use. Okay, right. This is what it was happened, guys. And finally, you can come out and see your cluster successfully dropping or not. Suppose you have to see that information. Let you come out and see. Yes. Now there is no clusters in my database. The cluster successfully be dropping here. Okay, now. So this is one of the small topic, the cluster mechanisms in our database. Understand now? Right, guys. And one more topic is there in SQL part. So that we will be discussing on Monday session. And in the next week, okay. So after that last topic, user defined data type, some topic is there. If it is finished, then we enter into PLSQL part. Okay, right, guys. So I stop it today, and thank you so much, and we will meet on Monday session.